Hi everyone and welcome. As promised, here is the review for the midterm exam. Asks us what principal will earn interest of 1820 at 3.25% for 8 months. So let's take a look at, write down the basic data. Interest is 1820. The rate is 3.25%. That's a decimal 0.0325. And the time is 8 months out of 12, so 8 over 12. We're looking for the principal. If we look at our IPRT formula, in order to calculate P, we know that that is simply I over RT. So we put the numbers in here. Principal is the interest, 1820, over the rate, which is 0.0325, the decimal, times 8 over 12. And that comes to $840 then would be the principal. This question here says, compute the amount of interest on $875 at 11.5% per annum from May 29, 2013 to August 13, 2013. So what we need to be able to do here is to tease out the basic elements. So we know the principal is $875. We know the rate is given to us at 11.5%. So we'll take 11.5%. We convert it to a decimal, 0.115. The time period. Well, what we need to do is go to our table here, and we look at May 29th. If you look up May 29th in the table, May 29th is the 149th day. And if we look at August 13th, same year, it is the 225th day. That's 76 days. Okay, so we know it's 76 days. So again, we're looking at IPRT triangle. We can do that. And in this case, what are we looking for? Well, we're looking for I. Okay, so I then is P times R times T. So we simply plug in the values we got, 875 times the rate, 0.115, times the time, which is 76 over 365. It's 365 days in a year. We calculate it to be 76. And this comes to interest of $20.95. Good. So the third question says, what payment is required to pay off a loan of $1,750 at 7.25% 14 months later? We know the principal is $1,750. We know the rate is 7.25%, which in a decimal is 0.0725. We know the time is 14 months. So 14 over 12. Everything has to be relative to a year. So that's 14 over 12 is the time. So in order to be able to do this, then we really need to think about what is the payment. So we need to think about it in terms of a value, be it a future value or a present value. So when we read this question, what payment is required to pay off a loan of $1,750? The payment will be the amount to pay off the loan. So the loan started, or the present value of the loan, at $1,750. Now we're going to pay some amount greater than $1,750. So we're really looking for what we call the future value here, which is the amount that we need to pay off in order to get rid of this loan. So when we think of future value, the formula for future value is P over 1 plus R. Okay, And so we can do that straightforward here by plugging the numbers in. The principal is 1750. 1 plus the R, in this case the rate in this particular case is 14 over 12. That converts to a decimal is 0.0845833. You want to get as many significant digits on that as possible. So if we do the crunching on that, that's $1,898.02. So we draw a little timeline here. You can think that the loan was $1,750 to start with. Time marches by. In fact, 14 over 12, which is really 1 month, 1 year, 2 months. So at the end, you're going to have to pay $1,898.02 to pay it off. The next problem says, what sum of money will accumulate to $539.04 from January 1 to April 7th of a given year at 11.4%? So, you know, always find good with these is to be able to draw some sort of timeline in order to help resolve the problem. So right now we're saying what sum of money will accumulate to. So accumulate to means that at the end it'll be $539.04 there. And we're looking for what is the amount that is required at the beginning in order to accumulate to that. Now we're given some data here. It is 11.4%, and we should always convert that to a decimal. So that is 0.114. Okay, so that will give us the rate. We have this amount here, 539, would be considered the future value. We're looking for the present value. And the trick we have is time, and it says, okay, January 1 is the start date, and April 7th. So let's figure out how many days. So January 1 to April 7th, all we need to do is figure out what is April 7th. We look at our table. April 7th is the 97th day of the year, so we got 97 days really of accumulation going on here. So we know that in the future value is 539.04. We know the rate on this is 0.114. And we know the time is 97 days out of 365. So that's basically what we need to plug into the formula. We know we are looking for the present value, so we say, okay, present value is what? Well, the present value is the future value divided by 1 plus RT. Okay, so we just know that. So we just basically fill in the blanks here. So that's 539.04, 1 plus the rate, which is 97 over 365, times the time, which is, that is the time, times the rate is 0.114. If we do the math on that, we will get 523.19. So what effectively it means is if we put $523.19 into the bank, earning this amount of interest for this amount of time, we would have this at the end. Now, you should always think about these. If you can't figure out what the difference between future value and present value is, future value is the date in the future, and it will always be a higher amount because the interest will accumulate as it moves along. So the smaller amount will be a present value. So there's the calculation on. So the next question asks, determine the accumulated value of $4,100 compounded semi-annually at 8% for 7 years. So again, we have to get the basic values out of that. So what we're saying is we have $4,100, so that's present value is 4,100. The interest rate is 8% annually. Is 8%, and it's compounded twice. So what we got to do is divide that by 2, and we get 4% per compound, which is 0.04. And it's for 7 years. 7 years, and there's 2 compounds a year. So that's a total of 14 compounds, okay? So this would be considered as N. So in order to do this particular calculation, then what we really need to do is we're calculating a timeline here, and we're saying, okay, we know what the value is now. We don't know what it is in the future. So what we're looking for is what we call our future value, okay? So we have to consider what is the future value formula. So future value is simply the present value 1 plus I to the n here. So our present value then is $4,100. 1 plus the I is 0.04 to the n is 14. We do the math on that and we get 7099.87. So effectively what we're saying is that 4,100 will grow in 7 years to $7,000, almost $7,100, just shy of $7,100. A loan was repaid in 7.25 years by end of month payments of $472. The interest was 6.12% compounded monthly. How much interest was paid? Okay, so we've got some basic information here. We need to know that the loan was the time was 7.25 years. And it's an end of month payment. So this is what we're dealing with here whenever we have a stream of payments. This is an annuity, and this is a simple annuity here because it's an end of month payment. And the payment is $472. So effectively we're paying $472 a month. And the interest rate is 6.12%. Okay, we think that we've got this taken care of now. We have to take it's monthly, so we got to take 6.12% and divide it by 12 and turn it into a decimal. So this will come to a percentage rate of 0.0051. Okay, in decimal terms. So this right here will give you the interest rate, which will be 0.51%, and divide that then by 100, and you will get this here, just to be clear on how that's calculated. So we have a simple annuity here, and we know that we need to calculate the annuity using the annuity formula. So we're looking for the value of it. And if we know the value of the annuity, or how much the stream of money is now, in other words, this $472 is pumped in every single month. And if we can find the current value of how much that's going to be worth right now, we'll compare it with how much we're actually paying, $472 a month. So let's find the present value of that annuity. So just do the annuity formula. It's 472. 1 minus 1.0051 to This is 7.25 years. This works out to 87 months, by the way. That's how we do that, 70 times 12 months per year. Okay? So what we can do then is we'll do the minus 87, which is the value of n. Okay? And this gets divided by 0.0051, which is the rate. It is a simple annuity. We run the numbers through that, and we will get the present value is $33,097.21. In other words, this stream of money, 472, paid for 87 months. The present value now is $33,000. Now, you know and I know that there's $472 for 87 months being paid. In other words, this is the actual amount of money that we have going out of pocket. So if you were to take the 87 payments and multiply it by 472, we would get a number of, let's do the math on that. 87 by 472, that's $41,064. Okay, so the total payments that were made were $41,000. The present value of those payments was $33. So the difference between this number and this number will be the amount of interest that you actually paid. So the value of interest would be $7,966.79. This is the amount of interest, and that's really what the question is asking, how much interest was paid. You are owed payments of $400 today, $500 in 5 months, and $618 due in 1 year. Let's draw a little timeline for that. Today, 1 year now, and 5 months. Okay, so let's look at the amounts again. There's 400 due now, there's 500 due in 5 months, and there's 618 in 1 year. So that's the basic scenario set up. You have been approached to accept a single payment in 9 months from now. So let's draw, so this is original, and this is the alternative. So a single payment in 9 months of some amount. We don't know what the amount is, okay? It's some amount. So the basic question is, and how much does that amount need to be? Well, it really depends on the interest rate, and we're told that the interest rate is 12%. So in order to do these types of problems, we have to find the focal date. The focal date is the date that we're interested in order to solve the problem. So the 9-month mark. So really, what we need to be able to do is to say, what is the equivalent amount of these amounts? What is the equivalent value of these amounts at the 9-month mark? So effectively, we've got to do 3 separate calculations here. First of all, we need to take this 618 that we're originally going to pay in 1 year time. We're going to bring it back to the 9-month mark. 1 year minus 9 months is really 3 months. So we're bringing it back. So we're finding the present value of $618 3 months before. So this would be 618 would be considered future value just because we're working backwards. So that's one we need to do. The next one we need to do is there's $500 that was supposed to be paid in 5 months. Well, let's just bring 5 months forward to 9 months, which is really 4 more months. So what would be the future value of $500 in 4 months' time? And the same thing here, where we got the amount now. Well, we got to bring it ahead 9 months. So effectively, what we're doing is bringing all the original amounts to a point, and the point is the alternative option point, which is 9 months. So what we need to be able to do is 3 separate calculations. 400 needs to be brought ahead by 9 months, 500 needs to be brought ahead by 4 months, and 618 needs to be brought back by 3 months. If we total those up, this amount, and this amount, that will be the same amount that we'd be willing to accept on that 9-month date. So really what we're doing here is 3 separate calculations, okay? So in the first instance, what we're trying to do is we are taking the, I'll just call this one number 1, call this one number 2, and I'm going to call this one number 3, okay, for the simple. So what we have in the first case is we have a present value of 400, and the rate is 12%. And when we think of that 12%, it's do you have been approached? Single payment of 9 months from now. Interest allowed $500 per annum. So effective 12% per annum. So effectively, this would be the amount of interest that we're dealing with here. And so what we need to do is to find the future value in 9 months. Okay, so we're just doing a future value calculation. So what we're really saying, if we put this in English, what is the future value of $400 in 9 months at 12% interest? Okay, now if you do a calculation on that, all we're doing is using the future value formula. That will come to $436. Now, for the sake of brevity here, I'm just doing this without doing the calculation, but we're calculating the future value of an amount of money, $400, bringing it ahead in 9 months, or 9 out of 12 would be the time, and the interest rate would be 12% per annum. So it's an annual interest rate, so that would be 0.12. So considering those, we would get $436. And then in the second instance, then we look at number 2, it's $500, so the present value is $500. We're bringing it ahead for 4 months, so the future value in 4 months. And again, the rate is 12%. Same exact calculation, just with the numbers changed. So we're asking, what is the future value of $500 in 4 months at 12%? And if we did the math on that, that would be $520. Okay? The third problem right here, we need to take this 618 and bring it back by 3 months. So what we're asking here is, we know our future value. The future value is 618. The rate is 12%, same. And the present value in 3 month par. So basically, we're bringing this back. So we're asking us, what is the present value of $618 back 3 months at 12%? And if we did the math on that by calculating present value, it would come to $600. Now, in order to be able to say what amount would you accept on this particular date, well, we take this one, and this one. So if we take the future value of the first one, the future value of the second one, bring them ahead, take the present value of the last one, bring it back 3 months, we would get these numbers here. We add these numbers up, and that would come to $1,556. In other words, we would accept $1,556 at the 9 month mark to be equivalent to, and that's how you do that problem. What's the cumulative value of deposits? $2,000 made at the end of every year for 3 years if interest is 6% compounded. So what we've got is, we have, again, a timeline is always so critical in these. It makes it so much easier to do when you have a timeline. So we've got at the end of every year for 3 years. So here's year 1. Okay, next we have a question. What is the accumulated value of deposits of $2,000 made at the end of every year for 3 years if interest rate is 6% compounded quarterly? So our payment is $2,000. The interest rate is 6% compounded quarterly, so 6%, so we got to do that. 6% divided by 4 is 1.5% per quarter, which is 0.015, okay, in a decimal. We need to think about the decimal. So what we got here, looking at this, it says that the contributions are made every year for 3 years. So we got a number of contributions of 3. Okay, there's 3 contributions. This particular instance, and we look at this and we say to ourselves, is it such that the number of payments and the number of compounds are the same? And they're not. So this requires us to calculate a value of C in order to be able to resolve this problem. So how many compounds per year? So we got to think about compounds per year is 4 compounds per year. And we also have to think about what is the revised value of the rate. So in order to be able to do that, we got to calculate P. And in order to do that, P is 1 plus the rate to the number of compounds. So this would be minus 1, sorry. So this would be 0.0613636. So that would be how to do that. So now we got to calculate future value because we're bringing it ahead forward, the accumulated value of deposits. So the future value of the deposits would be simply the payment times 1 plus this new version of the rate, which is 0.0613636, to the number, which is 3 minus 1 over 0.061363. And this then would be calculated as $6,375.71. So that's how you do that calculation. The next one, we're looking at number 9. Roxanne contributes $167 at the beginning of every 6 months into an RRSP paying interest of 8.9% compounded semi-annually. Now, I did say to you guys, look, we're not going to be dealing with the annuity to do in this chapter, and this is an example of annuity to do because it's at the beginning. My mistake. What I've done is I said, okay, look, I'll just ignore that. We'll do it as a regular annuity. And look, I want it, when I asked you to resolve this, I asked for the major details. As I say, I'm looking for methodology. So what I'm going to do is I'm going to resolve this as per an annuity due. But if you understand the concept of an annuity due, you will know how to do a simple annuity. So I'm going to show you the more complicated way, which I didn't ask you to do on the exam, and we'll resolve it from there. So she's putting $167 into this every 6 months. Okay, and it's an annuity due because she does it at the beginning of the month. Now, and the so this is the payment. It's 8.9% compounded semi-annually. In other words, this is done twice a year. So we need to think about how that works. So what we got to do in this particular instance is do a little bit of math on the interest rate. And so it's 8.9% is the interest rate. It's compounded semi-annually. So we need to take 8.9%, divide it by 2. Okay, so that would be 4.45% per compound. And that would be 0.0445. Okay, so that's how that works. Now, let's look up the formula. What we're trying to do here is calculate the future value. She's going to contribute money in every so often, and at the end, we want to know how much. And in fact, in this particular instance, how much will it be worth in 35? So the future value in 35. So what she's looking at here is the future value. Okay. I got all this shagged up, so you need to scrap all of that. That's all going to be scrapped. Okay, looking at number 9. Number 9, Roxanne contributes $167 at the beginning of every 6 months into an RRSP, paying interest at 8.9% compounded semi-annually. Now, I will tell you, on the quiz, I said to you, no, I'm not going to have this, and there it is, lo and behold. So what I've done is I've made adjustments in the calculation. I want you to be able to do this, but for the purposes of the exam, I promised I would not have this in terms of annuity due. So the calculation for an annuity and the calculation for an annuity due, the only difference between the two is the fact that we have to add in a 1 plus the interest rate at the end of the formula in order to get the annuity due. So if you did it as an annuity, that's fine. My major focus is on method, okay? Method. So here's what we're going to do. We're going to resolve this now as per the question is asked, and I have made adjustments on the exam calculation. So here we go. In this particular case, we are making a payment of $167. So that's the payment. This is an annuity because it goes in at the beginning of every 6 months. In other words, we do it twice a year. It's earning 8.9%, and that's compounded semi-annually. Now, you will notice that it's every 6 months we make a payment. It's every 6 months that the interest is. So this is a simple annuity. Okay, it means that these two are the same. In other words, 6 months here in terms of the payment, 6 months here in terms of the compounding. So that makes it pretty straightforward. You need to recognize that. So okay, looking at number 9. Number 9, Roxanne contributes $167 at the beginning of every 6 months into an RRSP, paying interest at 8.9% compounded semi-annually. Now, I will tell you, on the quiz, I said to you, no, I'm not going to have this, and there it is, lo and behold. So what I've done is I've made adjustments in the calculation. I want you to be able to do this, but for the purposes of the exam, I promised I would not have this in terms of annuity due. So the calculation for an annuity and the calculation for an annuity due, the only difference between the two is the fact that we have to add in a 1 plus the interest rate at the end of the formula in order to get the annuity due. So if you did it as an annuity, that's fine. My major focus is on method, okay? Method. So here's what we're going to do. We're going to resolve this now as per the question is asked, and I have made adjustments on the exam calculation. So here we go. In this particular case, we are making a payment of $167. So that's the payment. This is an annuity because it goes in at the beginning of every 6 months. In other words, we do it twice a year. It's earning 8.9%, and that's compounded semi-annually. Now, you will notice that it's every 6 months we make a payment. It's every 6 months that the interest is. So this is a simple annuity. Okay, it means that these two are the same. In other words, 6 months here in terms of the payment, 6 months here in terms of the compounding. So that makes it pretty straightforward. You need to recognize that. So this is the basic gist of how we need to do a little bit of assessment. Now, because it's 8.9% and it's compounded semi-annually, what we do is we take 8.9%, we divide it by 2, and that will give us 4.45%, which converts to a decimal of 0.0445. Okay, so that's important for the purposes of calculating the I value. Now, okay, so if we're doing this, then what we're trying to do is take $167, we're multiplying them up for a period. In the first instance, it says how much will the RSP add up to in 31.5 years. Okay, so this is what I call A. How much will it be there in 31.5 years? Now, we got to think of how many periods is this. This is every 6 months, so that's 31 years is 62 plus 1. So this is 63 compounding periods. So just so you see where I got that, 31.5 years represents 63 semi-annual periods. So the basic formula on an annuity due would be FV due equals PMT 1 plus I to the n minus 1 over I. This is where the annuity due part comes in, times 1 plus I. Okay, so this is the annuity due part. So the only difference between the equation when it's regular versus annuity due is this little piece right here. So let's just plug our numbers in right here. So effectively then, this is a payment of 167, 1 plus 0.0445, which is our interest, to the 63 over 0.0445, and that's minus 1 there, times 1.0445. Okay, so this is the basic equation. And when we do all the math on that, let me just get to the math on that, then would be $56,000, sorry, 963.31. So that would be the math on that. So what we're saying is all that money added up, and this is, I'm using the calculation for annuity due as per the problem, would be 56,000. Then we ask ourselves, how much really did we put into it? Well, we know we put real amount. We put $167 in it every 6 months for a total of 63 months. So that would be 10,521 was the actual money we put in. Now the difference between this and this then must be the amount of interest. So if we calculate 56 minus the 10,500, that would come to 46,442.31, and that is part B, which is how much interest accumulated. The final question, question 10, dealt with the vacation property. Okay, so vacation property was bought, making semi-annual payments of $7,500 for 7 years. First payment is due at the date of purchase, and the interest is 6% per annum, compounded quarterly. Calculate the purchase price of the property. This is a very similar problem. Now, as I say, I promised you in the exam that I would not ask an annuity due problem. The math on an annuity versus annuity due is only changed by this 1 plus the interest rate. So I'm looking for you to be able to do the problem. If you did an annuity due, great. If you didn't, that's fine as well. Okay, looking at number 10. Number 10 asks us, vacation property was bought by making semi-annual payments of $7,500 for 7 years. First payment is due on the date of purchase, and the interest is 6% per annum, compounded quarterly. Calculate the purchase price of property. Now again, this is another example of an annuity due because I asked if it's made at the beginning of the period. That's how you tell that. Now, I'm going to resolve this as if it is an annuity due. For the purposes of the exam, I said, nope, that's fine. You could do it as per normal, and that will be good with me. Okay, so let's just get some of the basic facts. The payment is $7,500, and the number of payments, what we got is for 7 years, and the payments are made semi-annually, so 2 times a year. In other words, there are 14 payments, so n is 14. The interest, in this particular case, it's 6% per annum, and we know that it's compounded quarterly, so it's 6% divided by 4, which is 1.5% per quarter, which is in decimal 0.015. Now, one thing you need to notice, the thing that I wanted to see here is you notice that the compounds were 2 times a year, and the interest was 4 times a year. So this is what we would consider an ordinary general annuity, which requires us to calculate the value of C. Okay, so we have to come up with a new value for the interest. So in order to calculate C, what we need to do is take the compounds per year and divide it by the payments per year. So the compounds per year in this case is 4. Payments per year is 2, so the value of C is 2. Now we can use that value of C in order to calculate the revised version of I2, which is what's used in ordinary general annuities. I2 is 1 plus I to the value of C minus 1. So this is 1.015 as per there to the value of 2 minus 1, and that equates to 0.0302250. So that's I2. Now, the rest of it's pretty straightforward. We take the present value is the payment, 1 plus I2 to the minus n over I2. So we got a situation then where this is an annuity due, so we need to go plus 1 plus I. That's the only real difference in it. So let's plug those numbers in really quickly. The payment, 7,500. 1 plus 2.03022 to the minus n. In this case, n we've calculated to be 14 over 0.3022 plus 1 plus 0.3022, which would be the I2 right here. We do all the math on that, okay? We do all the math on that, and we get 87,147.51. So that is the calculation for that final problem.